Hello everyone. So today we will be looking at mathematics and we will be solving a question from GATE 2022 from the chemical engineering paper. The question number was 28. So I will read the question. The question is, the area of a circular field is 25 meters square. The radius r is to be determined using the Newton Raphson iterative method. For an initial guess of r equal to 2.5 meter, the revised estimate of r after one iteration is dash. And this is a numerical answer type question. So we have to write the answers up till 3 decimal places. So from reading the question from the first time, we have an idea that we have been asked to use this Newton Raphson's iterative method to find the radius of the circle whose area is 25 meters square, and we are provided the initial guess of 2.5 meter and we have to find r after one iteration. Okay, so you can get the basics of this numerical techniques or the computational techniques related to mathematics from this NPTEL reference video. You can refer this video to get into the details of each of these numerical techniques to solve the equations. So let's start with some of the concepts that will be necessary. So here we have been asked to use Newton Raphson method. So what Newton Raphson method does is, it is basically a root finding algorithm. So let's say if I have an equation of the form fx equal to 0, then it will help us to find x for the Newton Raphson method. So for this there are various approaches such as bisection method, second method, but here we have been asked to use Newton Raphson method. So let's just look what Newton Raphson signifies. So let's say this is my x-axis, this is my y-axis, and I have my function. This is y is equal to f of x is my function. Now I have to find the roots of this equation. Okay, so the roots will be the value of x when y will be equal to 0. Okay, so in Newton Raphson method, as in fixed point iteration method, I will be starting at some initial guess xi. Okay, so xi is my initial guess. So from this point xi, I will be drawing a tangent to this curve at the point of xi, and the point at which my tangent intersects x-axis, that will be my next point. That is my xi plus 1. Okay, now again I will be finding tangent at this new point that I have obtained, that is xi plus 1, and the new point, that the third point that I will be getting is my xi plus 2. Similarly, I will be repeating this exercise and finding new tangents. So here from you can see that the interval in which the x is being predicted is getting closer and closer to my actual roots. Okay, so how we will proceed using this algorithm? So using this algorithm, so at this point I am calculating the slope, and from that slope I will be finding the equation of this tangent, and the next point will be the point at which this tangent intersects my x-axis. Okay, so the slope at this point is will that we can write it as f dash of xi. Okay, and the equation of my tangent will be, so it will pass through my xi comma f of xi. Okay, so that I will get it as y minus of f of xi is equal to my slope f dash of xi into x minus of xi. So now my second guess obtained is xi plus 1. Now I will be finding, so this xi plus 1 comma 0 will satisfy this equation, and by putting this equation, by putting this point in this equation, I will be getting my final iteration, the value at xi. So I will think y equal to 0 minus of f of xi is equal to f dash of xi into xi plus 1 minus of xi. So our main task was to find xi plus 1. So we can rearrange this equation and we can get this final form, that is xi minus f of xi upon f dash of xi. Okay, so this is my final form of the equation, which can be used to find the root of equation at the ith iteration. So once, so yes, so what we looked at upon was, given an equation f of x equal to 0, to find the roots of equation I will be using xi I will be using xi plus 1 is equal to xi minus of f of xi upon f dash of xi plus f dash of xi. So we will keep on iterating until my function value is very close to 0. Okay, or that is, I can say fi is less than some epsilon is equal to, let's say, 10 raised to minus 6. So once my function value is close to 0, then we can say that the xi is my solution of this equation f of x equal to 0. So this is the concept we will be using to solve the questions that was posed. Okay, so here we have been given area of the circular field is 25 meters square. Okay, so area of circle is equal to 25 meters square, and we know that the area of circle is given as pi r square. So here my function, that function will become f of r is equal to pi r square minus of 25. Okay, now the radius r is to be determined using Newton Raphson iterative method for an initial guess of 2.5 meters. So here we have been given r1 is equal to 2.5 meter, and we have to find r2 is equal to question mark. Okay, so we will first find the derivative of this f of r is equal to 2 pi r. Now at r is equal to r1, we will find the individual values. F of r is equal to pi 2.5 square minus of 25. So I will be using this equation to find my f of r. So you can calculate this using the calculator, and you will be getting a value of minus of 5.375. Okay, so this is my f of r. Now I need to find f dash of r r1 it is equal to 2 pi of r, that is 2 pi of 2 into 2.5, 2.5. Okay, so this will come as around 15.7. So we have find the necessary values, and now we will put into the equation of Newton Raphson, that is Ri plus 1 is equal to Ri minus of f of Ri upon f dash of Ri plus 1. So this will be equal to Ri is 2.5 minus of f of Ri is my minus of 5.375 upon 15.7. So here I is equal to 1, that implies R2 is equal to 2. You can calculate this and you will get a value close to 2.842. So this is what we have been asked to find. R is equal to 2.84, the value of R after one iteration, rounded up to 3 decimal places. So you have to keep this in mind. The value that you have to input should be up to 3 decimal places. Okay, so so yes, we have solved this question, and the answer should lie within this range, 2.830 to 2.850, and our answer was somewhere around 2.84. So this lies within this given range. Yes. So in this question, we looked upon how to use Newton-Raphson method to find the roots of the equation f of x equal to 0. Okay. Thank you, everyone.